Hello everyone, welcome back to Cryptoria. So as you hear, this is another English episode, which means we invited somebody to join us today. With me and Jian, we are talking about another very technical, at least for me, it's quite technical questions, technical topic. It's called memory layer. So if you guys are watching the news recently, then you definitely know which protocols we are talking about today. So we are very honored to have Muriel Medard. I'm not quite sure am I pronounce this right, and from Optimum. So welcome you, Muriel, and really nice to have you here today. So would you mind just do a quick intro to our audiences?
Yes, thank you very much, Vivian. Thanks, Jian, for having me. This is really a pleasure. And my name's Muriel Medard, as you mentioned, and I am co-founder, CEO of Optimum. And Optimum is a spin-out from my lab at MIT. I'm taking leave from MIT to pursue this full-time, and at MIT I hold the NEC chair in software science and engineering for the entire School of Engineering. I'm a full professor of electrical engineering, computer science, and have been leading for a couple of decades the network coding and reliable communications group in the research lab for electronics. So the work on which Optimum is based is a really long arc of dedicated development, discovery, implementation of entirely decentralized techniques. And, that's who I am. I've been very, very fortunate on the academic side. The work has been highly recognized. I'm a member of the U.S. National Academy of Engineering, the American Academy of Arts and Sciences, the German Academy of Sciences, the U.S. National Academy of Inventors. The academic career was going great. It was not something where I felt that I was missing anything out in being in academia. Quite the contrary, I'd been, ridiculously fortunate. But I really wanted to do this. I really wanted to see this technology that I had spent so much of my career, of my life pursuing, developing. I wanted it to come to fruition, and the time was right in Web3. So it was really a serendipity of, opportunity and readiness of the technology.
Okay, so since you already talked about that, I really want to ask you about, all the kids when they get asked by the teachers, what do you want to be in the future, right? Lawyer, doctor, musician, something like that, right? So is that being a professor is your dream, or being an entrepreneur is part of your dream when you were a kid?
Neither.
What do you want to be?
This is a complete accident. When I got to university, I really did not know what I wanted to do. I just had no idea. So I went to high school in France. I went through the French system. And one of the reasons I went to MIT was in the French system, you have to declare a little bit earlier what you want to do. And I just didn't know. I literally didn't know. I was 17 when I graduated from high school. Actually, I was thinking about that because yesterday my son graduated from high school. And he knows what he wants to be so much more than I do. I was entirely clueless. So MIT, you didn't have to declare a major the first year, and you could just take classes and find out. And to me, that was brilliant. So at first I thought I'll just be a math major. And the reason was I knew how to do this. So I'm like, okay, I know how to do this. This is, let's start with what I know how to do, But I love literature. And so I was doing a degree in math. I was doing a second degree in humanities, specifically 19th century Russian literature. And I took an engineering class just to see. I hadn't really been exposed to engineering. And to me, it was miraculous because, I liked the rigor of math, but I liked the creativity of literature. And to me, the two were completely separate. And here you have something which is rigorous, but is creative. Amazing, right? Absolutely amazing that you can be creative and be rigorous. Mind blown. So then, I went to electrical engineering. I enjoyed the math there. It was also something where I felt like I could do the labs, basically, mechanical engineering had lathes. And I was like, oh no, that's scary. Electrical engineering, I had done a lot of needlework when I was a kid. And I was like, okay, I know how to do this. It's like strings and, it looked a bit like just doing embroidery. I was like, I can totally do this. So that's how it happened. And then when I graduated, I didn't quite know what I wanted to do, but I stayed on for grad school. And then I just stayed on. I just did my PhD. I did my PhD in an area which my doctoral advisor had told me, why are you even working in this? It's dead. And I said, that's okay. It's interesting to me. I'll do something else. I mean, in my mind, I was just like, I'll just do whatever when I graduate, and I was already married. I had a kid. I was like, maybe I'll stay home. Who knows, And when I was finishing my PhD, my advisor, who's very, very famous in coding, Bob Gallagher, he was, for instance, the inventor of the low-density parity check codes. And we'll talk about coding a little bit more, I'm sure, through our discussion, which are, in my phone and everything, that's... he said, have you thought of being a professor? And I was so rude to him. I said, absolutely not. And I was like, look at you. Why would I want your job? It sounded like such an insane job. And I think he was a little hurt, but he was like, okay, And then I went to work at a research lab, again, just trying things. I did my doctorate in information theory, which... Interestingly enough, I had taken information theory, of course, when I was a graduate student, and it was a similar thing. When I took it, I said, well, that's interesting, but I'm never going to do this. This is useless. I could do it because I had the math background. But then, I started investigating it, and I started just saying, well, I'll just do a little bit of my thesis on information theory, just a tiny bit. And then the whole thesis became information theory. So here I've graduated, and I said, okay, I need to go back to being like a real engineer. So I took the only job I got offered. I had nothing to do with my PhD, right? And it went really well. And then it was a couple years out, and I was trying to figure out, okay, things at work had gone really, really well. Like, I was ranked top of the engineers in my research institution, which was not my plan, by the way, because my plan was just to have a job and figure, for a couple of years.
But you really make people jealous.
No, because I took this really high-risk project that nobody wanted, but I took it because I figured it was in optical network security. I was going to be really, really interesting, right? And I figured, okay, if the project fails, what's the worst thing that happens? They get rid of me and I find another job, right? I mean, I was always okay. I mean, I'll get a job somewhere. I've got good degrees. I ended up with 3 undergraduate degrees from MIT, which they don't allow you to do anymore, right? I mean, I was like, I'm a hard worker. I have a lot of knowledge. I'm pretty nice. Somebody will hire me, And I also discovered I really like working with students. Again, not something I was expecting at all. I got a chance to work with students, and then I was like, wow, this is great. I actually enjoy it. I did not expect to enjoy it. The way I looked at it, it's like I had my own kids. I didn't need to take care of other people's kids. That was too much trouble. And I enjoyed it. Yeah, and so I became a professor.
That is a life, c'est la vie.
C'est la vie, exactly. So it was not planned. Nothing was planned. But I think it was mostly about, staying very interested and feeling that what I was doing was super worthwhile and interesting. So, I was like, well, I don't know where things are going to go, but at least while I'm doing something, I should really believe that this is really interesting and worthwhile. And then you see where it goes, right?
So you work in the engineering and sectors. So how you work into the crypto industries?
Yeah, that's a really great question. So to me, it is engineering. By the way, crypto is engineering. To me, engineering is making things work, make things that work. That's what engineers do. They make doohickey. I say we're engineers, we make doohickeys. So we make stuff, right?
Okay, I learned
right.
new
I mean,
word.
that's what we do. We make things that work. That is what engineering is. And we get to create these things that work. We get to invent and create things that work. If it's not creative, that's non-engineering. And if it doesn't work, that's not engineering either.
Totally.
So as I mentioned, my doctorate was in information theory. Information theory is the basically field that deals with the fundamental limits of transmission, representation of information, right? And actually, fast track a little bit, fast forward to crypto. I mean, crypto is like the entire value is the information, right? That's it. Right. I mean, it's not the piece of gold. It's not, it's not the house. It's the information. So it's basically really has sublimated value into the information. And then I had done work also on network security, particularly right after. So my first academic job was at University of Illinois, Urbana-Champaign. And there was another new faculty there, my wonderful, very sadly departed friend, Ralph Coder. And he and I started to look at whether you could represent the actions that are taken in an optical network when there are problems in the network, so recovery actions, for faults. And could we use coding theory? And I'll say in a second what coding theory is to represent those. And there was a very recent paper at that point, actually from Chinese University of Hong Kong and from Bielefeld University in Germany. So it was Oswede, Li Tsai, and Young. And that was looking at doing some manipulations inside the network. And so Ralph and I started looking at that. And we said, well, we'll give it about a year. We'll try to see to what extent, for this to really make sense, it has to be that what people do now has to be at least representable algebraically. And this is when I get to saying what coding theory is. So coding is basically algebraic representations of the data. And what that means is you create equations that allow you to recover the data. So, the simplest idea is you have, say, two unknowns, x1 and x2. And instead of telling you x1 and x2, I give you two equations, say x1 plus x2, and maybe x1 plus 2x2. Okay? And if I give you those two equations, you can recover over the original x1 and x2. But then all kinds of interesting things happen. If I only give you one equation, say x1 and x2, I've actually done cryptography. You can't figure out what x1 and x2 were if I only give you one equation. That's actually the basis for what's called quantum safe or post-quantum crypto, is exactly what I just mentioned. That's exactly the basis. Of course, with a lot more, interesting stuff around it, but that's sort of it. Maybe your x1 and x2 are actually themselves combinations of other variables, effectively. And then maybe you may have, say, 100 variables, but because those are only combinations themselves are about, say, 10 variables, then you should only need 10 equations rather than 100 equations, right? You just need as many equations as you have independent variables. That's actually the basis for what's called source coding or compression, like something like if you have a gzipped a file. That's something similar. Okay, so it's all about making equations. The other is then in network coding, how do you actually make these equations inside the network? And the first thing Ralph and I did was say, okay, originally people were sort of looking at the network and saying, can you build it by doing this at this node? But then somebody would have to know the entire network and tell every node what to do. It's not going to happen. That's not decentralized, right? And getting back now to Web3, to me, what Web3 is the logical extension from Web2, and it has to be decentralized. If a system's not decentralized, it will not survive, right? It can be locally centralized, but it cannot be overall centralized, right? Look at the systems that have worked, long-term technological engineering systems. The electric grid, it is not centralized. There's not a single entity that controls the entire electric grid. And often failures are actually because it was too much centralization. Look at Web 2, look at the internet. It's not centralized. And again, some of the big issues that pop up is because too much too much local centralization. So it has to be decentralized, not necessarily for philosophical reasons, although many people espouse it for philosophical reasons. To me, it has to be decentralized for engineering reasons. You cannot make something robust that's big and centralized. You just can't. So, going back now to the coding, we're like, okay, people are trying to do network coding, but they're doing it in a centralized way. That's going to be a curiosity, okay? You need something that's decentralized. But first of all, thinking back a little bit, if you really have to know everything that's going on in the network, every single node, then it has to be centralized. So can you do a single collapsed representation of the network? And the answer was yes. And so that was the first thing that we did with Ralph, which was this algebraic representation of the entire network. So no matter how big your network is, it could be the entire world, it could be 3 nodes. It's one matrix, okay? And now you go, okay, it's just one matrix. Now, how do I pick the coefficients? I started doing a lot of work with Ralph, some other collaborators, and in particular my former student, Tracy Ho, who's actually, I think one of you is from Singapore. She was from Singapore. We started doing work on trying to figure out, how do you now pick the coefficients now that it's a single matrix? And the answer is the following. And I'll go to give you a little bit of intuition before we go to that. So remember I told you the 2 equations, x1 plus x2, x1 plus 2x2. What if I had given you other equations? What if I had told you that the second equation was x1 plus 3x2 or 2x1 plus x2? It would also have worked, right? Almost all the equations will work. If you have 2 equations, 2 unknowns, yeah, sometimes you can have degenerate equations, but almost always it works, correct? So now, why not pick the coefficients in your equation? Remember the 1 for x1, the 1 for x2, the 1 for x1, the 2 for x2. Why not pick them randomly? Then every node in the network is picking the coefficients randomly. And it doesn't matter how big the network is. And it's because in the end, all you need is you have the entire network is just a matrix. And all you need is for that matrix, just to be a little technical, to be invertible. That's to say that it's a system of equations that you can recover the original data from. That's it. Okay, now, tons of math behind it to show that it works, to show that, what representation you need for the coefficients, blah, 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 right? But the intuition is really simple. And then you go, okay, I don't care what the network is. As a matter of fact, even if you told me what the network is, I could not do better than choosing things randomly. And the different nodes are choosing them in a completely distributed, completely decentralized, not distributed, right? Because distributed means there's still somebody calling the shots, right? Distributed is there's a boss and the boss distributes the work to different workers. Decentralized is everybody just does whatever, right? They've agreed on how to operate together. And that's the basis for Web3. So what we're talking about is then I came at this going, I have a network. I want to operate it optimally. To operate it optimally, I need coding. Because coding, information theory, is about the optimal representation of information, of the data, right? And the network is about managing the data. So I need information theory. And it has to be decentralized. Otherwise, the thing's just not going to work long term. What do I do? And that was it. And so then, huge amount of work and trying to figure out, security, Byzantine failures, everything you can imagine in there, right? So a lot of work after that, but the intuition is actually very natural, I would say. It's a very natural intuition. So we started working on that. We started looking with my former postdoc superintendent Deb, actually, for instance, at what happens in gossip. And gossip will be familiar to many folks listening to our conversation, because it's, for instance, what happens in libp2p, it's like the basis, for instance, in the block propagation of Ethereum. So all of that aspect, which is highly, again, decentralized, was a really fertile area for investigation. And then you look at, what are the delay benefits? What are the bandwidth benefits? Again, how do you ensure security, particularly under Byzantine attacks? And so I'd been working on that. And then about a couple of years ago, one of my friends and colleagues I'd known for a long time, very active in Web3, Shorim Vishwanath, came to me and said, Muriel, the stuff you've been doing, network coding, I think it has to have an application in Web3. And I said, well, it's funny you should say that, because we had so we'd been working on this for a long time. And in particular, I'd been working on it with one of my co-founders of Optimum, who was my former postdoc. And we had so his name is Kishore Kanwar. He had been a postdoc with Nancy Lynch and myself. I'll talk about Nancy in a second. We had just about a year before that, a paper, actually with Nicholas Nicolaou, who's one of our engineering team members, a paper that showed huge benefits from using in a decentralized system for this memory layer. So now we'll get back to the beginning of the memory layer, the beginning of your questions, going back to that, how you could do things in a decentralized way much more cheaply. So we did some experiments over AWS, and we were just getting amazing results. And I said, it's funny you should mention that, Shriram, because actually we've been working on this, and yes, you're correct. This should have a huge benefit. So that's how we got going. So actually, going back to Kishore Kanwar, one of my two other co-founders, the third one being Kent Lin, who joined us later, who was also in Boston at the time. We can talk about him in a little bit. But Kishore came to work. He had actually been working at Wall Street in TradFi, and he came to work with Nancy and me. And Nancy Lynch actually was my predecessor in the NEC chair for software science and engineering that I mentioned I have. And if you look at something like Tendermint, it's based on her work. So when you think of the trilemma, the CAP theorem, she's one of the authors of the CAP theorem. So she actually had, and she's one of our advisors, by the way, for Optimum. She's one of the Optimum advisors. So she and I had been working together for years, teaching together and pursuing research together. And so, she has such a central role in Web3 in terms of laying the foundations for the theory of Web3 earlier than me. She started working on this in the 80s. And so Kishore, the reason we started working together is, she understands decentralized distributed systems, parallelized systems in a way that, a fundamental way that I would probably think nobody else in the world does. And, I understood coding, in particular network coding, very well. And so we came together and we said, okay, if you really understood consensus, you really understood coding, what would you have done, right? If the coding people had been thinking about consensus and decentralized systems, and if the decentralized consensus people had been knew about coding, what would they have done? Let's go back and redo this. So that's what she and I started thinking about. And this was about a dozen years ago. And we said, well, we need somebody pretty special to help us in leading this research, in pursuing this research. And we managed to recruit Kishore. I never thought we would be able to recruit somebody from Wall Street, right? I mean, just if nothing else, the salary, postdoctoral is not the same. And he took it, and I remember, well, I'm not going to ask why, because I don't want him to change his mind. But later I was like, why? You're a smart guy. What's going on in your head? And it was very sweet. He said, I would never have this opportunity again. No matter what happened, I would never have the opportunity to work with Nancy and you, right? Like he said, just working with one of you by themselves would be like a lifetime opportunity. Working with the two of you, it's just never going to happen. I don't care what happens with the salary. So, and then the thing is, we kept working together even after he went to academia, he went to industry, and we just kept working, on the side all the time on pursuing this. So when Sriram said, hey, look, I think that the stuff you do is ready, that the industry is ready for what you're doing. Went to Kishore, and the same way that before, a dozen years ago, I had said, hey, are you ready to just drop everything and come join us? I was like, are you ready to just drop everything? And the answer was yes, So it's been a, interesting path there. And then, so we had been working on this really just, if you will, kind of as infra. But we needed the expertise on the Web3 side. How does this really connect to Web3? And Sriram introduced us to Kent Lin. At the time, Kent was also in Boston. He was at Harvard Business School. And we just hit it off. It was clear that, it was the right trio. It was the right mix. It was funny because, of course, Kishore and I had been working together for years, and I thought, well, somebody might feel a little weird coming to work with two co-founders who've been around together for a year, but we just had the right, the word chemistry is a little overused. It's the right chemistry, but also just the right complementarity and philosophy. So that's how the company came about.
Yeah, that is really hard. There's somebody said it's really hard when you find the founders or your co-founders and your colleagues. It's even harder than you find the wife or husband.
Yeah, because in a way, because you're going to go through ups and downs. You're not always going to agree. There's no way, right? And you have to be able to have, very open discussions, and you have to be able to disagree and then just keep going,
Yeah, and everybody has to holding back for everybody, for each other's.
Exactly, yeah, exactly. But I think part of it was, like I said, it was the right mix. And also it was very clear how we completed each other, And so I think the core aspect is to have a lot of respect. If you have a lot of respect for the things that people do that they're really good at, and you also, very candid about the stuff you know how to do, the stuff you don't know how to do, and, what we're going to have to find out. And sometimes you're like, okay, does any of us know how to do this? Okay, no, we have to go. Let's go find somebody who does, We've also been super, super fortunate because our investors, when we were looking for investors, when people were asking, what are you looking for? I said, we want investors that have three things, One is that they're knowledgeable. The other one is that they're supportive. And the third one is they're involved, right? If they're involved and not knowledgeable, that's not good. If they're involved and knowledgeable, but they're not supportive, that's also not good, right? And, so it's like a stool, right? You need 3 legs, right? Because if you're supportive but not knowledgeable, well, that's nice from making me feel good in the morning, but it's not going to make the business
the things
go
happen.
Better.
Yeah,
exactly. So we really gathered just an amazing set of investors who are all 3, and I think being very very open about the things we know, the things we don't know. Also, it's not always the things that you think are going to be hard that are hard, and not always the things that you think are going to be easy that are easy. Because it goes both ways. So, being able to reach out and feel very comfortable reaching out, that has been great.
Yeah. So, by the way, you mentioned about investors. I'm very curious because Gia and I once were starting a startup before, and we were trying to pitching to the investors. And so I'm really curious how you pitching to investors, how you explain what you are doing, because I'm quite sure the investors, they don't understand all the mathematic things and all the theoretical.
And they shouldn't, because. So let's go back, Dan, to something you asked at the beginning, which is, what is the memory layer? And so, first of all, I think one of the things that's a little different about Optimum than maybe some other projects is that, remember, there was a very long arc of development, right? So when we're going to the investors, and particularly say now at this point, you already have a lot more proofs of concept. You already have, it's way beyond ideation, right? You already have something where you can go, look, this is what it does, and it does it better than anything else. And by the way, we've done the math. Nothing else will do better. There's something about that. Like, the math says it does it. Here, let me show you it does it. And by the way, you also can't do better, right? So that's part of it. But let's go back a little bit into this memory layer. So remember going back to, the whole development network coding for us, and this randomized coding, RLNC, randomly network coding. What is it doing? So it's basically propagating, including storing in a completely decentralized way, data in a network. Now, let's go to Web3. So, if you think of like the Ethereum type of vision of Web3 as the world computer, right? So what is a computer? It's a good question. I have one in front of me, but what is this thing, right? So, a lot of computing that sort of came about really kind of after World War II or during World War II, was very, very, how would I say, motivated and accelerated by the Second World War. So right after the Second World War, John von Neumann, who at the time was in the U.S., and people may remember him. If they saw Oppenheimer, he was one of those scientists there. So he asked, a bit the question, what is a computer? And basically, this is what's called the von Neumann or Princeton model. It's held the test of time. And it's like you have an input, that's good because you have to tell the computer to do something. You have an output, the computer has to be able to tell you what it did. Okay, so far so good. And what's in the middle? You have basically the compute, what we would think of, say, the CPU or GPU or something, PU, right? And then you have a bus and you have the memory, and that's it. And everything falls within that. So let's think of something in, like, again, let's think of Ethereum with an Ethereum virtual machine, or let's think of Solana with a Solana virtual machine. Those are basically like the operating systems, right? And then you can write programs on top of it, right? So I can use an Ethereum virtual machine to do something, right? And then you go, okay, well, what about the memory? So, if you think of something like DA was a first step where they went, I shouldn't have the memory inside my GPU. Like, you can, but that's not how you build a computer, right? Like, to have all the memory inside the CPU or the GPU, it's very expensive. It's space that you're using, it's compute space that you're using for memory. That's not going to scale. But you need that bus, which is the propagation, and you need the memory. And let's call all of that the memory layer, right? There isn't that much in Web3 around the bus and the memory. Okay, so you have the compute, and if you think of something like Bitcoin is also a compute, but it's a little funny. It's not like a full operating system that you can do whatever you want on, right? It just does a certain set of instructions. It's like, like my computer here is a computer, and right over there I have my thermostat. I'm not going to program I'm not going to program an arbitrary program on my thermostat, right? That's not but it does what it does really well, right? It just does a few things. It brings the temperature up or down, which is kind of like what Bitcoin does, right? It just does a few things. It does it really well. It's like but from a computation point of view, it's like the equivalent of my thermostat. It's just built to do certain things, and then that's it, right? And that's all I wanted it to do, so that's okay, right? Versus something like Ethereum or Solana, where I wanted to be able to do a variety of different things, right? The virtual machine. So what we're doing is to say, okay, but if you want to do this memory and propagation, so that's to say, being able to propagate, being able then to access, being able to read and write down the road in the most efficient way, in a completely decentralized setting, you need coding. And that's what we do. So we start with the propagation, with the bus. Why? Because as in order, if the propagation is no good, then who cares about the rest, right? So if you've ever built your computer, and I'm sure some of the folks who are listening to us, so some of your listeners will have built their own computer, right? You know that you need to figure out what CPU you want. You need to figure out what bus you want. You need to figure out the memory, right? And if you chose like a fantastic CPU and a fantastic memory, and then you chose like a really slow bus, it's not going to be very good, right? So your whole system will only work as well as the weakest element in your system. So we start with a bus, right? And that's our first product, which is Optimum P2P. By the way, when you're building your computer, if you're my son, you also figure out those lights,
yeah, those fancy lights.
A lot of the gamers, of gamers, they like all those lights, shiny, yeah.
I know if he's in his room because I can see the lights, But just to be clear to everybody listening, those don't actually help.
Yeah.
Somebody else can make the little funny lights for Web3. Decentralized LEDs. So that's basically what we do. And we're in testnet right now. So we went to, going back to this issue of getting the really good advice from your investors and your partners, we did a lot of thinking about our go-to-market. And finally what we decided was, okay, we could try to go to L1s, and there's interest and there's been pull there. But, who actually runs Web3? Like, who is actually doing, if you will, the work? It's the node operators. They're the folks that are actually running this. So if you look at the node operators, then you go, okay, what do they care about? APY. And how can we help them with this? So we went to node operators and we showed them with Optimum P2P the benefits that you can get. And, we've been publishing on this. Actually, we'll be publishing again maybe later this week or next week, more numbers. And the fact is, our testnet, which is very decentralized all over the world, over 100 nodes all over the world. If you compare the state of the art, the lib P2P with Optimum P2P, we just, we routinely do 2 times better, and in some cases way, way better, like 10x, okay, particularly when it's congested. And then, when we went to node operators, and we've been announcing, and there'll be a big announcement actually later this month about our partnerships with node operators. When we went to node operators and we said, okay, here's, we had done a really sophisticated analysis of the different benefits they could get, whatever, and we would start talking and they were like, okay, I want it. It'd be like the calls were, we'd be scheduling 1 hour after 10 minutes, like, Muriel, I don't want to look at your stupid. It's like, we get it. Just give it to me. This is simple. And that's actually what you want. So going back to the question you asked, Viviana, about, investors and the math, if you have to explain to them why this is clever math, it's like, okay, so you're good at math. Good for you. That's nice.
They don't care.
It's nice, Go write a paper, versus this is what it does for you. And you want those sales calls, those partnership calls that are super short, because you want to just be able to show what you did. So our first product is Optimum P2P, and we're partnering with Ethereum validators, and they've been great, by the way. And again, listening, hearing what they have to say, hearing what they think, absolutely crucial. And it's really, becoming a student again. You're really, you really have to step back and go, I'm learning, and it's really interesting. It's really refreshing. It's really motivating to do that, and also feeling that you're providing people with something that is intrinsically valuable, that it really is something that they can use. And basically, that's what we're doing for our first product. And then, we're starting with the bus, and then we're expanding into the memory, right? Just like von Neumann told us, first, what's the simplest memory? It's not the random access memory. It's a read-only memory, the ROM, right? So a lot of crypto is that way, right? You write once and then you read many times, and then you just keep writing more, but you don't change, right? A ledger, you don't change the ledger. You just keep adding to it, right? That's like a ROM. And then down the road, a full RAM, read access, random access where you read and write, etc. So that's our vision. And fortunately, we've done a lot of work on all of those parts of the vision. But then, of course, you have to instantiate it. You have to go with partners who really know what they're doing. And that's what we're doing. But I think in the end, we were talking about engineering. And as an engineering, you make things that work. It has to work. And it has to work much better than what's out there, right? Because people are not going to change for a slight benefit. People are going to change because you can make a radical difference.
So you just mentioned the first product is designed or building for the node operators. And, currently Web3, well, everybody talking about, the mass adoptions and ready for compete with Web2s. And is Optimum in the later stage? Is going to building for everybody use, for our daily use? I think that is your vision, right?
It does. Absolutely, it does. And actually, so let's go back to this full decentralization vision, which we mentioned at the beginning of our conversation. In a fully decentralized system, remember what we're doing is we're making those equations. Nodes right now are validators. They're doing the compute part, but they should be able to also run the bus and the memory. And that's a lot cheaper, a lot easier to get into than the compute part, right? I mean, right now, if you want to run a node, you have to have a fair amount of money. I mean, you don't need to be super rich, but you can't say, okay, I've got my wimpy little computer, which, by the way, I close every night. How can I make money out of it? You're not going to run a node that way, right? You need dedicated hardware. For certain chains like Solana, it has to be pretty expensive, right, for you to actually turn a profit. But now, if you're running Optimum P2P with this decentralized, RLNC-based gossip, you can use your phone, you can use your computer. It doesn't matter, right? You're just sending equations. If you did work, great. If you didn't, that's okay, so basically you get paid for what you did. You don't get punished for what you didn't do. Anybody, anywhere can do this, right? Anybody can run. We call these flex nodes. Anybody can run a flex node.
Okay. So basically you minimize or significantly reduce the entry barriers to
the entry barrier is
can...
almost nil. You just need to have a computer. And by the way, if you don't have a computer, you're not playing in Web3 anyway, right? But, right, I mean, you need to at least have some way to access it. So it's a precipitous drop in the barrier to entry. So now everybody's helping everybody out, right? I'm sending equations when I can. And if I sent equations that were helpful, I get paid. So if I did a little bit of work, I get paid a little bit. If I did a lot of work, I get paid more. It's completely fair. It's completely open. It's completely accessible.
Oh. So can I say that if one day, let's say, your goal, you get accomplished exactly what you want to do, and basically you can solve the trilemma. So every single one can be the no operator.
Yeah, that's perfect. Yes. And actually, we're preparing a paper right now. So I mentioned the trilemma, and that one of the authors of the original trilemma is one of our advisors, Nancy Lynch. So we're preparing a piece of work, and I hope you and I hope many of our listeners currently will read it, where we explain that the trilemma has been misunderstood. What the trilemma says is not what people think it says, And we're actually exactly preparing that. But you're exactly correct. That's brilliant. I love the way you're thinking. The trilemma doesn't say what people think it says. So yes, you can do what we're saying.
Yeah, because, the last 2 weeks we talk about Solana, we talk about Mega ETH, Solana and Mega is like a layer 2. They're super quick. Scalabilities comes like full scalabilities, but it's always get blamed by the centralization, because as you mentioned, it's super expensive to run a node. And I guess if Optimum can achieve what you want to achieve, then definitely you can keep the scalability. You have I don't know what's the theoretical TPS you can get at this point, but I guess you will be really quick as well, but also decentralized.
Yes, it's Optimum, actually. So that's why we call it Optimum. It's actually Optimum. So the idea is whatever resources you have, which may be a lot, which may be a little, whatever, we make optimum use of it. So we will give you as much as is possible in your network at this instant. Sorry, go ahead.
Okay, so that is actually not calculated as TPS. It's theoretical TPS as the other chain. So we're case by case. In your scenario, we give you optimum TPS by your scenarios.
Exactly.
Okay. Now I know what you guys doing. Now I understand. Cool. So by the way, so I do have another question. So currently, we do have a lot of discussions or blamed by the people just said there has so many blockchain space and there's nobody use. So because there's no applications, no that much applications in the Web3. And so if all of your chains, you guys building the TPS, the huge TPS, the 40th TPS, no one uses. So what are going to do in the later? So I do have the same questions. So just like the Optimum, we're building the such great infrastructures. And so who going to use, so what kind of the protocols or what kind of project going to use the Optimum, and what's your advantage or the competitive advantage to grab builders from other ecosystem to Optimum?
Yeah, so, to some extent, we don't want to grab builders from other ecosystems. We're scaling any chain. So let's go back to the computer. It's not the same people who are building the GPUs as are building the memory and the bus. It's just not. And it's natural as a technology evolves that you have specialization, right, in the different parts of the technology. So our goal is to scale any chain where, we're starting with Ethereum because it's a large chain. You need to start integrating somewhere. there is a recognized need, in particular because the propagation is slow. So we're not trying to grab from other people, we're trying to help everybody. In terms of the use aspect that you brought up, Vivienne, to some extent, it's a bit of a chicken and egg. If things are slow and expensive, you don't want to use them.
Yeah, so true.
If, in the early days of watching videos on a phone, it was expensive and it stopped all the time. And you're like, okay, I don't really need to watch that cat doing whatever it was doing, right? It's not until it's cheap and fast that you use it. For us, it's very cheap, right? Because remember, it's software. You're using resources that are already there. And we just make optimum use of whatever resources are available, right? And you go, I'm going to do the best we can, provably, in a decentralized way without having to figure out who does what. I'm going to do the best we can with what we've got, okay? And then that's it. So now you're doing, okay, I've allowed you to do the best you can with whatever resources are available, whoever's helping out right now. We're all helping each other out. And then the speeds are much, much faster and the throughputs are much, much bigger. So now you're enabling more of a Web 2 style experience over Web 3.
Okay. Yeah, okay, I got you. Because we watch some of your YouTube of your speech. So when we watch the YouTubes, I'm really curious how that's going to be happen. So how everybody talking about to make Web 3 just like how you like the Web 2. I'm really curious how that's going to happen.
That's right.
But today through our conversation, I get it. I get it how that's going to happen, and I'm sure it's going to happen. You convinced me.
Fantastic.
Actually, I want to ask you one more question. Could you try to give us or our audience some actual examples, like in 10 years' time or until Optimum fully accomplish your goal? What are those things that will be or looks or does differently comparing to what we have now?
Yeah. So I think that currently you need to put together things in a pretty complicated way, say, to make an L1. So to me, an L1 is like an operating system, right? And generally, if you were to build an operating system, and by the way, there aren't a lot of operating systems, right? Generally, I mean, there are some, right? So presumably at some point, there'll be just a few that people find are good enough, and maybe a few specialist ones for certain very tight set of requirements for some reason or another. You shouldn't have to think about your bus and your memory, right? And that's, I think, what will happen. We'll have a bus and a memory layer, which is entirely decentralized, making use of all the resources that people have. They have a little bit of bandwidth, they have a little bit of memory, and they are able to make use of that productively to help others and get value, get compensated for helping others. So I think what will happen differently is that whole part of Web3 shouldn't have to be something that people think hard about. That should be transparent, right? Right now, it's like the early days of computers where you're still having to, you still have a single person pulling the whole thing together and the operating system and this and that. It's like, you can't scale that, right? You'll have the people writing applications, you have the people writing operating systems, you have the people, designing the CPUs and GPUs, you have the people designing the memory and the bus. Those often, by the way, go together very tightly. And that's who we are. That's us. That's what we know how to do. So, it won't be all aggregated. You can't be good at everything all the time, Eventually you have to specialize. And so we'll be providing that layer. And what this means is that it will really free, so it'll be easier for builders, right? It'll be easier for the people making basically the VMs, the operating system, the L1s. It'll be easier for everybody. I've been an engineer for a long time. I remember when I would program and I would have to keep track of memory leaks. Nobody keeps track of memory leaks anymore, right? I mean, maybe in some areas, right? But like really, like I had to figure out what was going on in the hardware. I would have to put pointers everywhere. Like, that's ridiculous, right? Nobody keeps track of memory leaks. You shouldn't have to keep track of memory leaks. It's basically the same thing, right? As the different parts of the technology get specialized and get better, different players don't need to worry about it anymore, right? And people shouldn't have to worry about their memory layer. We can take care of that. We don't tell people how to build their operating systems, which is why you were asking, Van, how do you get builders? We're not. We're actually trying to help them. We're not trying to take them from anybody, But what we're doing is we're doing in a virtualized, decentralized, completely open way.
We had a conversation with the Red Date Technology CEO, and he had an opinion is about there's later days that everybody going to have their own chains. So maybe 3 of us currently, we can have our own chains while we have had this conversation. And maybe 2 of them, they will have their own chains. So each companies may have their own chains. So what you just like when the later days, every company or every group or every DAOs, they going to building their own chains, and they will have their Lego toolbox. So one from the memories, and we can use this, and the one from others, and because everything is decentralized, and it's just like a toolbox, right? So I just put this together, and I just make my Lego ready. So it's just suddenly put everything together in my mind.
That's right. And I think, that's very much the vision. I think, but the one thing I would say is, remember our name. We're Optimum. So we are the best. We're the best.
Yeah, the best. Yeah. You're the best one of it.
We proved it.
Cool. Muriel, so on the later part of our interview, so I do have one question just for you and for the next generations. So you are the ranked number 1 globally in the networking coding. And so how do you hope your work influence the next generations of researchers and entrepreneurs?
Oh, wow. That's a heavy question. Wow. I think it's really good for people to feel that they have, let's say, the space to explore things that maybe at the beginning look a little weird. Okay, so feel free to look a little weird. I think, my colleagues for a while when I was doing all this, I remember we got a lot of pushback. Why are you doing this decentralized stuff? Like, who cares? And, my answer was, well, I care. And so I think it's important to have the space to let people explore, to let people follow an idea for a long time. I've been working this for over 20 years. And roughly that's how long it takes for all the thought process. I'm sure somebody would be faster than me, but that's how long it takes me, And so, feel that you can go off and do things that take a long time, that maybe look a little weird, as long as it's interesting, as long as you think that eventually it's worthwhile. And so I hope that people give themselves that permission, and I hope people give others the permission to do that.
That is really insightful. I think starting from today, I'm going to look in the weird things around my life.
Why not? Why not?
So the last questions for you is, I know you are teaching and you are researching. And
I'm
now
actually on leave right now. Yeah, I'm on leave. I'm doing this full time.
That's the question I want to ask. How do you feel from like a transform from a academia or like scholars or researcher to a
entrepreneur? Yeah.
Do you feel like it takes time to adopt or to make yourself familiar with this role changing?
There's definitely a lot of learning, right? There's definitely a lot of learning. One of the things I found is that there was more transfer than I had realized, because, I generally managed a large research group. I had always done work that did a lot of theory, but also did implementation. So that was very helpful. Managing people, managing a group of students is similar. We were talking about fundraising. I mean, I always had to raise funds and get support, basically get money to pay the students. So I always had to figure out the finances of my lab. So it's a huge learning curve, but I think if you've been a faculty member that was always raising a lot of money, doing a lot of projects, making sure, projects that had to work, and doing a lot of the theory and having to manage a large group, a lot of it is transferable. So, yes, it's a huge change. Yes, it's scary. I was surprised, though, at how much transferred.
Do you enjoy it?
I do. I do. I do. But, for me, I enjoy it because, remember, it started from the tech. So I'm really enjoying, seeing the tech adopted. That's quite a rush. That's a huge high. Yeah.
So by the way, how you balance your life and work? You're definitely quite busy, and you have a son, you have a daughter, you have such happy families. How you balance those things?
Sometimes the house doesn't look so good.
Okay. So do you do the sporting, or do you have any hobbies?
So my husband and I love to hike, long distances. We just came back from a long distance hike in the south of France, and I run. I used to do competitive sports, but I don't have time for that anymore. So
we love competitive sports. We're starting for tennis,
Oh, fantastic!
It's really release. It's really when you high pressure, just hitting the balls is really release. Yeah. Cool. Thank you, Muriel.
Thank you. It was really a pleasure.
Hope you're enjoying our conversation, and I learned a lot.
I enjoyed it immensely. It was really wonderful talking to both of you. Thank you for the invitation.
Thank you. It's really just like the personal tutorial with you.
Yeah, and also eye-opening because at the first place it's just like a memory layer. It doesn't strike that much to me, but after your explanation, now we know why so many investors and people start talking about Optimum, and they said that you guys are the future of the blockchain.
Thank you very much, and it was really a pleasure, and I hope to talk again in the future. This was very enjoyable.
Yeah, definitely. We will be in US maybe end of the year or beginning of next year. Yeah,
super.
So we definitely let you know, and maybe you can grab a coffee sometimes.
I would love it.
Great. Thank you to joining us today, Muriel, and I hope all of our audiences are enjoying our conversation. And let us know if you have any questions, and hopefully we can pass your questions to Muriel, and hopefully she had the time to answer your questions.
Or maybe she knows the answer, maybe. It's not always the case.
Anyway, thank you so much to join us, Muriel. Thank you again, and thank you everybody for listening. So I'll see you next episodes. Bye.
Bye.
Thank you. Bye-bye. Bye-bye.
Taught me to sing, makes my life worthwhile. How that music gets me high, brings tears to my eyes. My hips are swaying side to side, my lungs they